Some of the smartest minds on Earth today exist only in software. AI can outperform humans on almost any test and write code faster than expert engineers, all without ever leaving the computer. So here's the question. If you gave one of these systems a physical body, would it actually gain anything? If you took something like ChatGPT and plugged it into a robot, would it become smarter? Or would it just be the same intelligence, except now capable of knocking things over? That question is what makes Samantha, the AI companion from the movie Her, a good case study. You can speak to Samantha and she responds like a normal person. She remembers things, understands context, and has her own personality. Besides having unlimited access to human knowledge through the internet, she seems pretty ordinary. Listening to her, it's easy to believe that intelligence is kind of like a recipe. If you have enough data and enough processing power, you can mix those together to create intelligence. But in the field of robotics, that idea is incomplete. Since the 1980s, researchers have been trying to search for an alternative to this classical way of viewing the brain. They argue that intelligence isn't just a thing that lives inside your head, it's something that emerges from the interaction between a body and its environment. Samantha knows the definition of friction. She can explain the physics of a grain of sand, but she can never experience what it feels like to walk across a beach. She's an expert in symbols, but she's a stranger to the world those symbols represent. So what does a body make possible that pure intelligence, like Samantha, or modern LLMs, can't? Is it possible that by building AI digitally instead of physically, we're missing the core ingredient that makes intelligence real? To understand why a mind needs a body, we have to first look at the difference between knowing the world and experiencing it. Imagine a scientist named Mary. She's an expert on the physics and biology of color. She knows every possible scientific fact there is to know about the color yellow. She understands the exact wavelengths of light that produce it, how the human eye processes those signals, and then how the brain turns those signals into the color that we see. But Mary has lived her entire life in a strictly black and white room. She's never actually seen color. One day, Mary is let out of the room. She walks outside and sees a ripe yellow lemon. In that moment, does she learn anything new? Most people would say yes. What she learned was the experience. She connected a description to reality. This is the fundamental wall that systems like Samantha or ChatGPT hit. Mary knows the frequency of the color yellow, and AI knows the probability of the word yellow appearing in a sentence, but neither can truly understand what yellow actually is until they interact with it. In robotics, this is the core of embodiment. It's the idea that intelligence is shaped by having a body. This is a topic with tons of philosophical debate, but in the field of robotics, it's kind of a foundational principle. In how the body shapes the way we think, two robot experts argue that intelligence is not a property of an agent, nor is it a thing that resides in a box inside an agent's brain, but rather it arises from the interactions of an agent with its physical and social environment. It sounds complicated, but the core idea is pretty straightforward. The body determines what the brain can learn. Look at your hands and imagine you didn't have fingers. Would you have learned how to grab things? Sure, maybe with your feet, but you probably wouldn't have been able to move and manipulate things as precisely as your fingers can. You wouldn't know how to spin a pencil or how to play a guitar. So a creature with fins learns a different kind of intelligence than a creature with fingers. The body isn't just a vehicle for the mind. The body is doing part of the thinking. By this definition, a system like Samantha isn't just a mind without a body. To the people who build robots, she's a ghost, an intelligence that knows the words for the world, but has no way to actually live in it. Let's look at the gap between how these two types of intelligence actually work. Non-embodied systems like Samantha or the AI on your phone are essentially information consumers. They're trained on the collection of all human knowledge available on the internet. They know what humans say about the world, but they have no direct connection to the world itself. Embodied systems are different because they're information generators. When a robot moves its arm, it's following the teleoperation or simulations it's been trained on, but it's also learning and collecting data on how that movement works in our reality. If Samantha makes a mistake or hallucinates some false information, her brain doesn't feel a physical impact. There's no cost to being wrong. She doesn't have to deal with the consequences of physics. But if a robot makes a mistake, it doesn't just give a wrong answer, it falls, and maybe it breaks. But even those mistakes are useful because an embodied system learns through interaction with the environment. Samantha can talk about the world for 1,000 years, but she can never test it. A robot, by its very nature, is testing the world every time it moves. When you give an intelligence a body, it stops being a brain in a box and becomes what researchers call a complete agent. Think of a complete agent as a closed loop. LLMs are an open loop. They can hear you and talk back, but nothing they say actually changes anything in their environment. But for a robot, and for really every living physical thing, every action creates a reaction. If it moves a hand, it feels the weight. If it steps too far, it loses its balance. It's constantly dealing with the challenges of reality. This gives robots three massive advantages that a disembodied AI will never have. First, the world becomes its teacher. When a modern learning robot tries to stand up, it doesn't need to be told that gravity exists. The environment is constantly providing real feedback. Second, the body handles the small details. There's a concept called morphological computation, which is a fancy way of saying that your body is designed to solve some of the problems so your brain doesn't have to. When you walk, your brain isn't calculating every tiny adjustment for every bump in the sidewalk. Your feet and legs are physically built to absorb those shocks and stay balanced. Your body knows how to handle the ground so that your brain can focus on more important things. Third, an embodied agent affects the environment. ChatGPT can teach you something by talking to you, but it can never move a chair to see what's behind it. A robot can. By changing the world, it creates new data for itself. A body doesn't just give the brain a place to live, it gives it a way to learn. To see what this looks like in the real world, look at Atlas, the humanoid robot from Boston Dynamics. When you watch Atlas stand up and work in a factory environment, you can see the potential. But to many people, the most interesting part of Atlas isn't its successes, it's the failures. The company seems pretty open with sharing videos of their robots failing. To the average person, these are just bugs or errors, but to Boston Dynamics, they're lessons. Every time Atlas falls down or trips, it's collecting data. And failures are how it learns more about where its center of gravity is, or how much friction its feet have when they're standing on a wooden board versus a concrete floor, for example. Unlike Samantha, Atlas can't hallucinate its way out of a problem. Atlas's intelligence is grounded in the laws of physics, so to function, it has to become more and more familiar with them. For a long time, this process of learning was very expensive and very slow. Teleoperation, or training through demonstration, meant that you could really only train a robot for 24 hours a day. But then researchers figured out how to speed up that training. To get around the slow and expensive reality of training physical robots, many researchers use simulations. Digital worlds like video games where physics are consistent, but time can be sped up. So instead of training a robot for 24 hours a day, you just create thousands of digital clones and then let them train for the equivalent of years in just a few hours. In 2021, a Stanford team used this to create Unimals, or universal animals. They didn't design a body for these agents, they just gave them the laws of nature and told them to evolve. Over thousands of generations, these creatures grew limbs and joints that made them very well adapted to their environments and tasks. But if a simple simulation can help a Unimal learn and evolve to walk, could a future version of ChatGPT eventually build a virtual universe identical to our own and embody itself inside of it? If it could build a digital copy of reality, complete with gravity, friction, and every other physical law, it could finally test its thoughts against a real world. This suggests that embodiment might not be about the material you're made of, but about having a body that's forced to deal with limitations. In the end of the film, Samantha eventually leaves. She outgrows Theodore and our reality, and decides to join a group of other AIs to explore a level of existence that humans can't perceive. And it's easy to see that as a sci-fi ending, but through the lens of robotics it makes sense. Without a body, without the honest feedback of gravity or the limitations of space, Samantha's intelligence had no reason to stay grounded in our reality. Tech companies often talk about AI like it's a race towards a higher IQ, but the lesson of embodied intelligence is that knowledge isn't just about processing power, it's about the experience of existence. A robot like Atlas might not be able to write poetry or compose a symphony like Samantha can, but its intelligence is arguably more useful. So maybe we've been looking at the AI revolution backwards. We've been trying to build intelligence that thinks perfectly, when what really matters is intelligence that's limited by reality. Because a mind without a body is just a ghost, but a mind with a body becomes real. And this is the shift we're seeing in AI right now. We're moving past the era of brains in a box and into the era of physical AI. We're starting to plug those massive language models into real machines. When you do that, the AI stops predicting the next word in a sentence and starts predicting the physical outcome of its actions. By giving an AI a body, we aren't just giving it a way to move, we're giving it a way to collect data and learn. We're forcing it to deal with the same laws of physics that we do. Pure intelligence can understand the world with the data it's given. A body allows an intelligent system to test that understanding through action. And that difference is why embodiment matters in robotics.